Okay, so in this electrolysis lab here, we're going to be using a power supply to run a non-spontaneous reaction. So for part one, we're going to be electrolyzing a solution of 1 molar sodium sulfate. Currently, the solution here is a green color because I've added some bromothymol blue. We know bromothymol blue switches from yellow to blue, depending on whether it's acidic or basic respectively here. I'm going to pour this solution here, about 60 milliliters here, into this U-tube here. The U-tube just helps me separate the electrodes, just to make sure that no sparks jump across the electrodes there. But technically this can be done all in one container here. So I'm just going to fill up this U-tube here. Again, this green color here would be the end point, the transition point here. It's a roughly neutral pH here. For the positive and negative ends of this power supply here, both alligator clips here are currently holding onto a carbon graphite electrode, and we're going to make some observations of what happens at each electrode. So just before I drop these in here, I'm going to turn my variable power supply on. I'm going to crank up the voltage here so that the voltage across the two leads here will be about 9 volts, and then what we can do is we can just drop these in and we'll just make some observations. So here's the red lead and there's the black one there. We'll give it a little while for the reactions to occur here. Sometimes it helps to just shake it so the ions that end up forming, you can see what happens to the bromothymol blue. And then hopefully if this one, also shake that one there. There we go. Okay. So with these physical observations here, comparing it against bromothymol blue as an indicator here, you should be able to see the trace of the green that we began with. That was our control. This end here has actually become a yellow solution, and this end here has actually become a blue color solution there. Okay. So definitely a notable color change here. Just going to turn off the power supply. I'm going to pull out these leads here so you can make another observation. And there we go. Hopefully you can see the initial green color that it used to be. Okay, still at the bottom here. Those ions haven't completely migrated after the products have been formed, but this side is definitely notably bluer, and this one is definitely notably yellow. Okay. Thanks, guys. Okay, so for part 2 of this electrolysis lab here, this time we're going to do the electrolysis of a 1 molar copper 2 sulfate solution. So this one here is already a very deep blue color. We're going to fill up the U-tube again here. Remember, my variable power supply here is going to send in 9 volts. Okay, that's the electrical voltage that we're using to force a reaction to happen. Both of them are connected via alligator clips here. We're just going to drop the electrodes in once I've turned this on here, and then we're going to make some observations of what happens. So I'm going to crank up the voltage here. We have a voltmeter on this side here, so we can see what voltage that we're sending in. I'm going to drop in one electrode on the one side here, and I'm going to drop in the other electrode on the far side. So give it a little while for the reactions to occur here. Get this one a little shake here. You can see a little bit better. And similarly for this one here, a little bit of a shake. So by making some physical observations here, see if you can identify what chemicals have been produced. Okay. I'm going to just let this run for a little while here. The voltage is basically forcing the reaction to occur. The longer that I wait here, sort of the degree of completion here will be higher. Okay. So I'm just going to flip this off here. And I'm just going to just show you the electrode itself. Okay, not only can we make observations of the inside solution here. So here's the copper electrode. Okay. And on the other side here, similarly, here's our graphite electrode. Okay. We definitely see a little bit of cloudiness that's forming on either side here. That cloudiness here is indicative that there's a solid that's actually forming. If the solid and the sort of surface area on the electrodes were good, the solid can actually form directly deposits on the electrode. from the looks like here, it's look like forming a little bit of a suspension on either side. All right. Thanks, guys. All right, so this is part 3 of our electrolysis lab. This time the solution we're electrolyzing is a 1 molar solution of potassium iodide. We've added already some phenolphthalein inside here. You'll notice that this one here is remaining colorless, so we know that it's still on the neutral end towards the acidic side. I'm just going to fill up this U-tube again. Remember the U-tube here is actually connected, so this is technically just one beaker here. We're just using the U-tube here for demo purposes, just to make sure our leads can be far enough apart. So that's just 1 molar potassium iodide there. Okay. I already have my voltage here set to do 9 volts, but I do need to flip it on. I'll keep these here carbon electrodes here separate from each other. I'm going to turn it on, and then we're going to make some observations of what happens. Okay. So let's just drop one lead on the one side. We'll drop the other carbon electrode here on the other side here, and then we'll make some observations of what happens. Shake it up a little bit here so you can see a little better. So see if, based on those physical observations here, you can predict what's being formed at each electrode. Okay. This side here, the phenolphthalein is responding, that sort of a base is being created, or it's getting less and less acidic. On the other side here, again, you can figure out what chemical that we're forming, and it's giving us a sort of yellowy browny color. Okay. So again, what I'll do is I'll just flip off the power source here. I'm going to pull out these leads to stop the reaction, and hopefully we can have a nice comparison with what the overall solution looks like. So 2 ends. Okay. Thanks, guys. Thanks, guys.